All right, students, today we are going to learn lesson 1.3, which is over the midpoint and distance formulas. So first of all, I just want to go over what is a midpoint. A midpoint, when you think about a midpoint, you want to think of the middle. Okay, so here, in this box over here, if I draw a segment, so I'm going to draw a segment, and then I want to cut that in half to indicate the middle, I'm going to fold my paper in half, and I'm going to map this point onto this point, like this, so that they touch, and then I'm going to crease my paper, and then when I open it up, this right here is going to be the middle of this segment. You can also use a ruler and measure it and then measure the middle if that's easier for you. But for me, folding was easier. Okay, so here I'm going to label this D, and I'm going to label this one over here G, and that way I know this one's going to be O. And since this is the middle, I know that the DO segment here is going to be the same as OG, which is here. And we also know that point O is the midpoint of segment DG. Okay, next, segment bisector. Well, there are several different things that can cut a segment in half. Up here, we have a point that is cutting this segment in half. Think about the segment bisector as the knife that is actually doing the action of cutting something in half. A segment that intersects a line at its midpoint. Okay, so what geometric objects can act like a knife and cut this segment in half? Well, this segment right here could have been cut by another segment. It could be cut by a line. It could be cut in half by a plane. It could be cut in half by a point like it is right here. Or it could be cut by a ray. So all of these geometric concepts, they can cut this segment in half. Let's draw another segment here. I'm going to draw it down towards the bottom. Okay. And I'm going to label it A and T. And then again, I'm going to fold it in half to identify the middle. So I'm going to put the point on point, put a little crease. And when I open it back up, that little fold right there, that's the middle. So this is going to be my ant segment, where N is the midpoint. And then if you draw a ray like this, then this ray is considered to be the segment bisector of this segment. So let's write that out to the side. Over here to the side. So turn your paper. And you're going to write ray, NO, so the no ray, is the segment bisector of the segment AT. AT. And remember, you use segment notation over AT. All right. Let's do a few examples. The first example says point T is the midpoint of RS, segment RS. Find the length of RS. So notice how this RS, that's uses segment notation, and this one is RS side by side, but it doesn't have segment notation. When we're talking about this, that's a picture that we're talking about. When we're talking about RS like this, we're talking about a number. All right, so here, what we know is that we've got this mark, hash mark, and this hash mark. So we know that segment RT is equal to TS. And we're able to use the equal sign because these are numbers. If we were trying to say that these two segments were the same, we would use segment notation on top, but we couldn't use the equal sign because we don't say pictures are equal, we say numbers are equal. So we would have to say that these are congruent. All right, so just remember that with segment notation you have to use the congruent, and when there's no segment notation you can use the equal sign. And what do both of these equal? Well, that says 21.7, so let's write that down, 21.7. Okay, now the next topic in order to solve this is another rule. It's called segment addition postulate. And the segment addition postulate says that if you have this piece plus this piece, it's going to equal the whole thing. So let's write that down. RS, the whole thing, is going to equal the first segment, which is RT, plus the second, which is TS. So RT plus TS equals the whole thing. Okay, well, since each one of these is 21.7, I'm going to write down RS is equal to 21.7 plus 21.7. Okay, so when you add those together or multiply by 2, whatever you prefer, you get 43.4. Now look and see if they gave you any units, and they didn't. So whenever you don't have units given to you, you just use the word units. All right, next example. Point C is the midpoint of BD. Find BC, so find the distance between these 2 points. Okay, well, what I know is that BC equals CD because that's the midpoint. Well, this segment is represented by that expression 3x minus 2, and CD is representing this expression, which is 2x plus 3. So I substitute those expressions in for the corresponding segments. Now, that's all of the geometry that's involved. The rest of this is going to be algebra. So I'm going to subtract 2x from both sides. When I simplify the left-hand side, I'm going to get x minus 2. When I simplify the right, I get 3. Now I'm going to add 2 to both sides, and I get x equals 5. Okay, go back up to your instructions and you read. Did they ask me to find x? If they did, you can stop there. But if they asked you to find BC, you're going to have to plug it in. Okay, so BC, we know, is equal to 3x minus 2. Plug it in. So we know that BC is equal to 3 times 5 minus 2. So that means BC is equal to 15 minus 2. Therefore, BC is equal to 13, and we don't have any units, so we just put units. All right. Okay, so when do we use the midpoint formula? Okay, so here it says find the midpoint formula of P segment PR. Well, when it's on a graph like this, it's so easy to just look. There's the middle, identify the middle, and then just look at the graph and tell me what that point is. By looking at the graph, I can tell you that M is at 1, 2, 3, 4. So it's at 1, 4. But you're not always going to have a picture. And remember, whenever there's not a picture, it is a little bit more difficult. So let's go over here. It says you're trying to find the point in the middle. Find the midpoint of PR. But this time you're only given P is at -2, 5, and R is at 4, 3. So let's pretend like we don't see this and that we're given these 2 points and we want to find the midpoint. Well, we have to use something called the midpoint formula. Now, the midpoint formula, see how that's in the middle? The midpoint formula is kind of like saying we want to find the average of the x's and the average of the y's, because we want it to go to the middle, because average means to the middle. All right, so let's write that down. Midpoint is equal to average of the x-coordinate, comma, and this one's going to be average of the y-coordinate. Okay, so remember average, it's like when you're averaging grades, you're going to add up all your grades and divide by however many grades you have. Well, here I have 2 x-coordinates. So I'm going to add both of those up, and since I only have 2, I'm going to divide by 2. So here, I'm going to add the first x-coordinate plus the second x-coordinate, divide by 2, and then add the y of the first one plus y of the second one, divide by 2. So this right here we call the midpoint formula, and that will be on your formula chart so you don't have to memorize it. Now let's take this midpoint formula and use it to find the midpoint. Remember, this is your first point, this is your second, so this is your x1, y1, this is your x2, y2. So you're going to plug it in. M is equal to -2 plus 4 divided by 2, comma, and then there's your first y, so that's 5. There's your second y, plus 3 divided by 2. All right, add them together. I get -2 plus 4 is 2, so that's going to be 2 over 2. And this one's going to be 8 over 2. And when you reduce this, you end up with the midpoint being at 1, 4. And if you look, that's where it was when we looked at the graph. So we know we did it right. All right, the next example. Okay, again, here they want me to find the other endpoint. They gave me one of them. They gave me the midpoint, but now they want me to find the other endpoint. Okay, so looking at the graph, it is very easy to see that the other endpoint, which we call C, because this is AC, they gave us A, so C is at 1, 2, 3, 4, 5, comma 2. All right, now let's go back and manipulate our midpoint formula, because sometimes we're going to just be given A and M. Okay, so here what I want you to think of is that the midpoint is really the x-coordinate of the midpoint, comma, the y-coordinate of the midpoint. And what it equals is the average of the two endpoints, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay? So to get this xm, that is equal to x1 plus x2 divided by 2. And to get the y-coordinate of the midpoint, that's equal to y1 plus y2 divided by 2. Okay, so this is not new information. We just took this and expanded it out. Okay, so now let's pretend like they told us to find the endpoint of AC when we are given A is at 1, 6, and the midpoint, M, is at 3, 4. But we want to find C, the other endpoint, which is at, that would be x2, y2, because it's the other endpoint, the second endpoint. Okay, so remember that this is your x1, y1. This is your xm, ym. And we're going to take all of this information and plug it in right here. Okay, so I'm going to deal with the x's first. xm, which is 3, is going to equal x1, which is 1, plus x2, we don't know. So I'm going to write down x2. Divide by 2. Okay, we also know this one. So, and we know that ym, which is 4, is equal to 6 plus y2 divided by 2. Oh, I don't need that parenthesis, sorry. Don't mean to confuse you. Okay. So, I have a fraction on one side and a whole number on the other. Whenever you're in this situation, the easiest way to deal with this is just to put this over 1, because whole numbers we put over 1. 4 we put over 1. And then all we have to do is cross multiply. So cross multiply, you get 1 plus x squared this way, and this way we get 6. So equals 6. And then it becomes an algebra problem, minus 1, x squared equals 5. Not x squared, I'm sorry, I didn't mean to say that. X, the second x coordinate is 5. Now cross multiply, and I get 6 plus y2 is equal to 8. Subtract 6 from both sides, so the second y coordinate is going to be 2. All right, so remember that C is x2, y2, so C is going to be at 5, 2. And if you look, that's what we got before just by looking at it. So when there's a graph, it's really easy. When there's not, there's some algebra that you can show. All right, one more example. Okay. Distance formula. When we're trying to find the distance between 2 points, we use what's called the distance formula. And I want you to write this down. Distance is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, that's on your formula chart, so you don't have to memorize it. But just for convenience, I'm writing it up here. All right, so now if we're lucky enough to be given a graph, a picture, then there's a different way that you can do it. So if it's on a graph, you can use the Pythagorean theorem. And a lot of people remember the Pythagorean theorem as a squared plus b squared equals c squared. And remember, this only works for right triangles. So here, if I have this right triangle, where this is a right angle, then this leg squared plus this leg squared will equal the hypotenuse squared. Okay, so when you have this drawing, you want to draw in the right triangle and shade it in. Okay, to get from this point to this point, I had to go down 1, so I just drew that in. That side is 1. And this side over here is 1, 2, 3, 4, 5, 6, 7. So this side length is 7. So this one is 1 unit. And this side is 7 units. Okay. So this is my A, this is my B, and I'm trying to find C, the hypotenuse. So I'm going to plug it in. 1 squared plus 7 squared equals C squared. 1 squared is 1. 7 squared is 49 equals C squared. Okay, 50 equals C squared. Take the square root. So C is equal to the square root of 50. And I'm going to leave it like that because that is going to be the exact answer. If I asked for an estimated answer or a rounded answer, I'd plug this into my calculator and then I'd round to however many digits they asked me to round to. Okay, so now we're going to do the exact same problem, but this time we're going to use the distance formula up here. Okay, so here I'm given 2 points. I'm given t is equal to negative 4, 3, and I'm given r is equal to 3, 2. Remember, this is x1, y1. This is x2, y2. So now plug this into our formula. Distance is equal to, all right, the second one, which is 2, minus the first one, which is a negative 4 squared, plus, oops, I wrote down the wrong one, my bad, 2, that's supposed to be 3. I looked at the wrong one, so be careful, don't do that. Okay, so remember, these are the y's, so I'm going to use this one and this one. So 2 minus 3 squared, and then this one's going to be 3 minus the negative 4 squared. All right, 2 minus 3, when I take 3 away from 2, that's going to be a negative 1 squared. Now it's time to simplify. And then here, that's going to be a negative makes a plus. So that's going to be 3 plus 4, which is 7. So this is going to be 7 squared. And if you notice, you're getting some of the same numbers over here. So D equals 1 plus 49. All right, so D is going to be the square root of 50. Okay, now remember, so you've got a letter over here that's D. Over on this side, D stands for distance. And over here, C meant it was representing the hypotenuse of the right triangle. So I don't want you to get confused why you have different letters. All right, folks, that's it for lesson 1.3.